I am a marine scientist by training, but for the past 15 years, I've worked more in the science policy interface. So that is everything from working with the European Commission in Europe, and that made me move to Belgium to join first the European Marine Board, which is a leading think tank in marine science in Europe. And then I got increasingly interested in not only the science policy interface, but really connecting back to the research that I had come from and the ocean observations that I used to take part in. And that led me into the position I have now, which is Head of the Secretariat for EMODnet, which is the European Marine Observation and Data Network. It's one of the European Commission data services, which I'll tell you a little bit more about during this presentation. And this secretariat is implemented by Seascape Belgium, which is the employer that I work for now as Head of Marine Knowledge. So that's a little bit about me, and hopefully in this presentation you'll learn a little bit about the marine knowledge value chain, but also I'll share some personal perspectives as well from some expeditions I've done previously and my career pathway.
Perfect. Thank you very much. Also on the call, we have Michaela, who is part of the Women in Ocean Science team, and myself, Laura. If anybody has any questions throughout, feel free to put them in the chat or write them down so you don't forget them. I think Kate will also be doing a bit of a poll, so there might be an opportunity to put your questions in that. I'm sure she'll explain in a second. Otherwise, enjoy. Over to you, Kate.
Thanks very much. So yes, I'm just putting in the chat a link to the Slido that we will be using for a couple of polls in a minute, just as a sort of icebreaker to get us started. What I'm going to do is first just share my screen. Okay, so you should see the full presentation mode now. So I titled the workshop today, From Waves of Wonder to an Ocean of Observations and a Deluge of Data. This is because throughout my life and then career, I was first driven by a real curiosity for the environment in general, but then it really channeled into the ocean. Then I spent a lot of time going to sea myself, collecting research-driven data and ocean observations. And now I've moved into the space of marine data, how we share these data, what value we can draw from these data. So this is a whole pathway, a whole value chain really for marine knowledge that I wanted to share with you today. And hopefully by the end of this presentation, you'll know a little bit more about that marine knowledge value chain, what is really important when we're collecting data and how we curate it so that we can share it and use it. And also the power of these observations, the value of marine knowledge for society. I should say that this is mostly a European-centric presentation, and that's just the nature of my expertise, my background, but it's really set in a context of a global system. There's a big global initiative through the UN Ocean Decade, which my work is part of, and which hundreds or thousands of scientists and stakeholders across the world are currently contributing to. So it's in that global context that I say that. And then this presentation as well, it's really my personal take rather than a professional representation tonight. But you will see some of the work that I'm conducting with hundreds of partners across Europe for EMODnet. And where I'm using others' data, I'm recognizing those also in the presentation. So with that, I'd like to suggest that we kick off with a short icebreaker. So we've put 3 different questions in Slido. So what I invite you to do is to use the QR code, scan that if you have a smartphone handy, or go to the link that I've put in the chat that's on the screen, and then there's a hashtag number for the workshop tonight on Slido that you need to type in that long number, which will give you access to the polling for this workshop. And what I'm going to do whilst you are all accessing Slido, I'm going to bring up the first. Let me see. There we go. Okay. So hopefully most of you have now got or getting access. So I'm just going to run the first poll. You should see the poll coming up. And if you're on Slido, you should be able to vote for one of these options. So before we kick off, I'm just really interested to understand a little bit what has brought you here today. Are you completely new to ocean observation and marine data and just want to know more? Do you already use ocean and coastal data in your job or in any different applications and are interested to learn the latest developments? Maybe you're already in ocean science and you're interested in one of the aims of the workshop is to bring some information on how you can have a career that's beyond academia. This is something that I started in the research in academia and decided to shift into the science policy, for example. Or maybe you're just curious, you saw the link or someone told you, have a look at this, and you're simply curious, or there is another reason why you've decided to join today. Great, so I'm seeing a lot of people who are obviously using marine data already in some kind of applications, and also others that are interested in the career pathway as well, and some who are completely new as well. So that's great. It just gives me a sort of sense. We try with the workshop to explain any jargon. There will be a few slides that are relatively technical, but also explained hopefully in a accessible way. But don't hesitate to ask questions at the end if something is not clear. Then we can move on to the next one, which I'm interested to know where you're joining from today. So as I understand, the Women in Ocean Science Network, or at least Laura, is based in the UK. So I've separated that out just to see how many people are here from the UK, then European Union member states, other European nations, and then across the world. There may well be people joining us from all over. I can see Asia is already getting some hits in North America. That's amazing to see. And then some also from the European Union and United Kingdom. Great, thanks a lot for joining. And then this will hopefully help us guide the question and answers session near the end. I'd love to hear what you're hoping to learn about in this workshop. You should be able to type in a couple of words of text and that will appear as a word cloud when we stop the interaction. Laura, I can't see any results coming in. Oh, yes, they are now. Perfect. Amazing. Observation and data collection methods, storytelling aspects, stories through data. There'll definitely be some data visualization and link with storytelling coming up. Data science, science communication, both the collection and the personal stories, and some insights into the general topic and subjects. Fantastic. So what I suggest we do is we keep that running. I'm not going to close that. We can come back to it later. So if during the presentation you want to add some more topics, feel free. What I'm going to do now, though, is move back to the presentation so we can get started on the workshop. Normally what we'll do is if you have questions, as Laura said, please just type them into this Google Meet and we keep the Slido for the polling. I think that's probably the easiest. We will double check if the questions have been put into Slido as well. Okay, let me go back to the presentation. Okay, great. So hopefully as you read in the summary of this workshop today, this workshop is really focusing on ocean observations and marine data. What we're going to do is by the end of this workshop, you should understand and have some more evidence about what the value of marine knowledge is. What I mean by marine knowledge is really the observations, the data, and the insights we can get from those data. They become knowledge that can be used for evidence-based decision-making, policy-making, operations at sea, such as the blue economy, decisions on ocean governance and the management of our ocean and coast. All of these require information and knowledge. So I'm going to show you a little bit at the beginning why marine knowledge is so valuable, but then also dive into the actual value chain, because it doesn't just start with the data, of course, it starts with collection at sea, which can have challenges. So we'll have a little look at the different ways that you can observe and sample the ocean, particularly the in situ. So that means the in water or around the water collection. We're not going to dive into satellite data today. It's much more on the in water collection efforts. And then we're going to take a look at why the FAIR data principles are so important. I will explain what that acronym is and give you some information on that. And then we'll have a little look about the European Marine Data Services. There are a couple of key data services, one of which I work for now in my current role, and the whole sort of ecosystem of what European policies are shaping the development of these data services. Then we'll have a quick look at how Europe is contributing to the global ocean data ecosystem, just with a couple of short examples. And then we're going to come back to those FAIR principles, but also bring in two other acronyms, the trust and the care principles, which is increasingly important, not just to European services, but worldwide, also in the context of the UN Ocean Decade. And then I'm going to give some reflections that are perhaps more personal in terms of my career pathway to date, how I moved from research into science policy and beyond, and then how I've connected the dots to bring me back to actually going to sea and collecting data, which is not part of my current career role, let's say, but it's something that I have done and will continue to do, engaging in expeditions and in citizen science, which I believe is really a really important way to engage society. So that's, in a nutshell, what we're going to cover in the presentation. The first couple of slides then are about the value of marine knowledge. So you can see here some images, some articles regarding the polar regions, and in particular the Arctic. As many of you, I'm sure, know very well, the ocean has absorbed a lot of climate change up to date, including the carbon dioxide emissions. But we're seeing that the ocean, of course, is reaching its limit in a number of ways, but it's also reacting to this capacity. So the Arctic, for example, the Arctic Ocean is warming 3 to 4 times faster than any other region on the planet at the moment. We're seeing a lot of sea ice and glaciers around the world melting at an unprecedented rate. And not only is the ocean warming, it's becoming lower in oxygen. So we have a lot of coastal zones becoming very deoxygenated. We have natural oxygen minimum zones, but these are expanding. And the pH is lowering as well. We're having a more acidic ocean. And how do we know all of this? We know this because we have collected observations and data, both from the ocean, but also coupled with atmospheric data and terrestrial data. So all of this combined means that the marine knowledge component is really important to be tracking these changes. Then if we look at a sort of European Union or Europe-centric approach, the marine knowledge is already supporting a lot of European policies, the blue economy, research and innovation, and society. A couple of examples are, here you have a headline saying marine litter on the EU coastline is down by almost a third. So this was a decadal study which European marine data services like EMODnet contributed to. And it really shows that now, because we have data that's been shared, not just collected by hundreds of people, but shared in a fair way, we are now able to assess at the level of a continent how we're doing as society in terms of the levels of marine litter. And this shows a positive progress, which I'll talk a little bit more about later. There's also addressing pollution, invasive species, which in the different regional sea basins of Europe are big issues. Also, information on marine knowledge is really important for driving the blue bioeconomy as well as the blue economy. And the blue bioeconomy, I mean things like algae or food, aquaculture, and fisheries. And also, the knowledge is really important for the blue economy. So, for example, the offshore renewable energy sector, which is growing rapidly, it's growing because there's not only a demand, but there's also the knowledge to be able to put these offshore platforms at sea. And the knowledge comes from marine data that's been collected, shared, so that these offshore pylons can be situated in the right place, that they can be situated so that with sea level rise and climate change and ocean change, they will be stable, and also to minimize environmental impact. So all of these different approaches require marine knowledge of some kind. And then I mentioned the European regional sea basins, and that this talk is quite Europe-centric, but just for those who may not be based in Europe, just a quick overview of the different regional sea basins in Europe. They're not just geographically different, they're very different in their the profile of how they are. Some are very enclosed basins, Black Sea and the Mediterranean Sea, almost semi-enclosed as well. They all share some common characteristics, but display very different characteristics as well, because you have different regional influences and impacts as well. So for marine knowledge, it also has to be not just sea basin specific, but also down to even the very national or local levels to really be used. And some examples we can see in the Baltic Sea, the warming of the Baltic Sea, but also the Mediterranean is warming at a very high rate. And then on the left, you can see examples from my local area. I live in Belgium, and on the North Sea, the Belgian coast, the number of strandings of orca and also other whales has been increasing. Just before I left on an expedition in 2022, there was one of these strandings which really caught my eye, and then every year since then there's been a number of strandings, which is much more regular than I remember 5-10 years ago when I moved to Belgium. So there's a lot of information that requires marine knowledge to really understand, for example, why are these orcas stranding? You know, is it an environmental reason? Is it a human impact reason? And how do we piece those data together? Then a little bit about the marine knowledge value chain. So we're starting from left to right. On the left, you have really the data collection, the observations at sea. When you go to sea, you collect some data. And then you move to more the primary data that then needs to be managed in some way, where we do quality control checks, quality assurance checks, the basic level, let's say, of or first level of data management. Then it needs to be shared in a way that it's can be exchanged with other data. So you can integrate data from hundreds of different data collection efforts into one big consolidated data, which can then form maps and be visualized and be used as information, which then can be used for decision making and knowledge. And there are many applications that I've already mentioned some of the different sectors using these marine knowledge, but it's really important that the whole marine knowledge value chain is interconnected. So you have stakeholders, in dialogue with each other. And the work that I do for the Marine Data Services is really in the middle of this value chain. So the core work we do is between the data and the information, but we are very much in contact with the ocean observation community. And we're also very much in touch with the user community, the policymakers, the blue economy that require these data, so that we make the information available in a fit for use format, the right parameters, the right data products that they need for their applications. And here is an example of the value of marine knowledge for seabed habitats. Sorry, I'm doing this from home. There might be a little bit of noise from traffic. On the left, we have the observations that was on the left of the value chain that you saw. In the middle is more the work that I'm focused on, which is the information and knowledge sharing, where for example, a seabed habitat, you have a lot of information and different data points, and then you have information on, where were these data collected, and that's even before you get to the integrated map at the end. And then you can use these data for knowledge-based action. So this is an example from the UK where there are now conservation advice that have come out from these observations of seabed habitats that can then help society, blue economy, all stakeholders to recognise various areas where they need to particularly conserve based on the seabed habitats and the species as well in these protected sites. So the flow is really from the observations to the data management, which needs a lot of investment and human resources and expertise, both to collect the data, but to also manage and harmonise the data. And then the dialogue with the stakeholders to make sure those information and knowledge are, being used for useful applications. And then in the middle now, I've swapped the data handling information of where the surveys were to actually the final integrated map. So here you can see in the middle the seabed habitats map from EMODnet. This is called the EU CMAP, and it's a broad scale seabed habitat map for Europe. So I will show you the website later for EMODnet, but if you dive in there, you can actually, it's a layer which you can, zoom in on and really decide on a quadrant of area that you're interested, and then you can retrieve the data that is behind this data product. But it's basically built upon hundreds, if not thousands, of different data points from different data collection efforts, from benthic surveys, etc. That has been assembled by the team of EMODnet seabed habitats into this EU CMAP. And the other benefit of sharing all these information and making a map like this is that now this type of product actually has some kind of predictive capability. So basically, if certain data are missing, then based on the geological and seafloor environment, then the map and the product can infer what the biodiversity or the species may be like based on a similar area, that has similar characteristics. So it's a very powerful product, and one of the only ones that exists at the European scale like this. And how is it used? For example, in Europe, we have a Marine Strategy Framework Directive. There's a typo there, which is a bit unfortunate. It should say health, assessing the health and good environmental status of European seas. It's a directive which is not legislation, but it really is a guidance for member states to have to take observations, take data, and then submit their good environmental status assessments to the European Commission. So I should say it's not a law, but it is a directive, and there is a difference legislatively with those two. But I've picked out here two of the key indicators of MSFD, the biological diversity and seafloor integrity, which is very relevant to these seabed habitats. And by sharing these information, not just keeping it within national EEZ borders, but then sharing it and producing these European maps, it's possible to also assess the good environmental status of regional sea basins, or even the wider European seas and bordering oceans. So then now we're going to just take a dive into knowing that there is a huge value in the marine knowledge. How do we actually start collecting these ocean observations? So on the screen you can see an image from the Global Ocean Observing System, which is an initiative of the IOC UNESCO. This shows at the top the satellites and the remotely sensed observations, which are very diverse now, and you'll have seen pictures, I'm sure, from satellite-based imagery, which is very, very powerful for the surface of the ocean at the global coverage, but also on land and from space, etc. So that has a very powerful tool. What I'm going to talk today about is the other types of ocean observations, the in situ observations, which are collected in or around the water. The reason I'm focusing on this is that that is the focus of the data service that I work for, EMODnet, but it's also my background. I used to go to sea and collect research-driven observations and data using a number of these different types of platforms, and it remains the most diverse type of ocean observation. You have hundreds of different parameters that you can measure. You have tens, if not hundreds, of different platforms and sensors that you can measure. Everything from the temperature to the underwater sound to the seafloor benthic biodiversity and more. And the platforms range from really fixed platforms to research vessels to autonomous underwater vehicles, etc., etc. So there's a huge diversity, and yet there's actually not enough investment in the sustained funding for these types of observations. So we do have a lot of data out there, but they're often on sort of research-driven funding cycles, which can be, as short as 1 to 2 years, maximum 3 to 4 years. So there's not really the long-term sustained perspective that is needed if we want to maintain the marine knowledge for society. So here are some, very quickly, I'm not going to go through each one in turn, but some examples of ocean observing and monitoring of the ocean. All of these images on this particular slide are from research-driven observations, so academic research vessels, ocean buoys that are for monitoring and released by ocean or meteorological organizations. In the middle at the bottom, you can see the biofouling, the biodiversity that can grow on a sensor platform if it's left in the ocean for a year. I think this was from the Northeast Atlantic, for example. In the top right, you can see them measuring, they're just being lowered to measure and take a core of the sea ice to measure the Arctic sea ice thickness. So there are lots of different ways that scientists are measuring the ocean. Many of you, I would imagine, on the call today are either conducting this or have already conducted some of these yourselves. But there's also a whole opportunity for observations that engage wider society and citizens themselves. So these pictures, I think some of you on the call today are from an expedition that I did back in 2022 to the Norwegian Arctic. And the pictures are all taken by women that joined a Sea Women expedition in 2022. This was really a citizen science approach where we had to completely adapt the sensors and the samplers that we were taking and completely adapt the methodologies as well, because we were working from a vessel that was not equipped for research. We did not have a big winch with capable of dropping big instruments in the water. We just had a very small gangway that you can see on the right-hand side. We had to bring much smaller and cost-effective sensors, such as the Castaway CTD on the left, so that we could use that both from the vessel but also from a rib. And in the middle, you can see myself and Wendy from the Sea Women team, that we're on a rib. We're about to go in the water to snorkel and observe orca and whale behavior, but we're also taking a temperature profile of the top 10-15 meters so that we have some data that goes with the orca behavior information. So this, there is an adaptation that needs to be done, but it is possible to use other sensors and engage citizens, and there are lots of other examples. For example, the Secchi disc that's now used, it's an international program that's available for recreational boaters to use, coral surveys, etc. So again, many of you may have conducted these, but it's important to note that there are many different ways of conducting the observations and the monitoring, and that can include yourselves, even if you're not an ocean scientist at this point. Then, in terms of the next step on the marine knowledge value chain, we had data. What I'd like to introduce to you now is the FAIR data principles. These are really not just a philosophy, but they are critical for the data sharing and the actual use of the data by the end user. The acronym FAIR stands for findable, accessible, interoperable, and reusable. And it means that if the data are curated in the right way and have the right information collected together with them, then they can be used multiple times. For instance, you collect a temperature profile. If you just submit that to a data repository without information on who took it, which sensor, what was the depth profile, and many other information, then somebody else visiting that repository will find the data, but they probably won't use the data because they may not trust the data, or they're not sure of certain characteristics of the data, which is really important for their application. So the aim is to collect the data once and then to curate it so it can be used multiple times for many different purposes. So in terms of the FAIR principles, again, I've explained some of this already, but to go in a little bit more detail, the findable aspect is that the data needs to be made public in some way, and there are many repositories at national, regional, European, and global levels. They need to be accessible. So they need to be really open access, or at least open source, meaning you can see the data exist and you have the contact of the person to ask to get at the data. And then the data needs to be able to work together. It needs to be standardized or harmonized in different ways so that it's not just one data point on its own, but it can be really integrated into these maps and data products that are so useful that we've just been looking at. That's important for one parameter to be integrated, but it also, if you have good interoperability of data and standardization and harmonization of the data and the metadata, you can then start combining data from different parameters. And I'll show an example of that a bit later on. And then the reusability is really important. If we know, as I said, the provenance in terms of how these data were collected, who took them, and the whole chain of events, who has curated or managed the data and how, different quality control flags, for example, then we can have a lot more trust in the data. And we also need to know, are there uncertainties in the data? That's really important as well. For example, if we're doing modeling, computer modeling scenarios, or we're applying it to evidence for policy implementation. So all of these different aspects are really important in the data management and curation process. And then something that's really important to mention is that the FAIR data is only made possible by metadata, and those metadata also need to be fair. The metadata mean the information that describes the data. So who took the data, when and where was it taken, latitude, longitude, and GPS location, etc., etc. So I've already introduced some of these, but it's very important that the FAIR data and the FAIR metadata go together, so that we can then have the trust and use of the data multiple times. Then, in terms of I mentioned the standards and the harmonization. Interoperability is driven by the standards, and standards drive the interoperability. So it's really a virtuous cycle that all data repositories and services are typically applying standards and then harmonization of the data. In Europe, we use, or at least in EMODnet, we use the INSPIRE directive, which is an infrastructure for spatial information in Europe. So it's really a very important directive for geospatial data. And EMODnet, the data and the metadata are INSPIRE compliant, which it means multiple things, but the essence is the FAIR, which I presented just now. And this is really critical for sharing at a European level, but we also apply international metadata standards, such as the ISO standards that you may well have heard of. And then not just the data, but the way we share the data through different data services or web services also have to use open source and standards that are internationally recognized, such as the Open Geospatial Consortium, OGC, and we use GeoServer as well. So that's just a little bit more detail on the types of standards that we use. An example of a data flow, I've taken the liberty of taking some information from an open source slide that was online from a colleague that I have collaborated with on a previous expedition. This is work of Dr. Elizabeth de Bucherer from the Marine Observation Centre at Liz, the Flanders Marine Institute in Belgium. And this is in the context of a European infrastructure called LifeWatch that is doing all sorts of different biodiversity measurements, not only marine, I should say, but the example I give is the marine example. And this is a data flow of cetacean passive acoustics, results from some work on harbour porpoises. And you can see here from the left, again, the marine knowledge value chain from the data collection. Then it comes to a database, which may be a local database, such as a national database, or even a particular organisation database before it goes to national, and then starting to have object identifiers applied so that the data can be tracked. And then those data, once they have been curated to a certain level and they have the metadata, they can go into many different services. So for example, here you see two arrows. One goes into the LifeWatch Data Explorer, which is also a public service for LifeWatch, but it can then also go into other European services such as WOS, which is a ocean biodiversity and information system specializing in marine biodiversity, but also EMODnet, which has marine biodiversity information, but has much wider environmental data as well, and human activities information. So here's just a snapshot of the passive acoustic monitoring, and that will come back to another example of that later on. And here are the logos of Liz, LifeWatch, EMODnet, and Eurobis. Then I'd like to introduce you in a nutshell, really, to the European Marine Data Services. So these are the EU public services. I note that there is a huge pyramid of different services and repositories and infrastructures that feed into these. So the examples I'm giving are purely the let's say the top-down European Commission services, but they rely on a very large value chain of different data management procedures and inputs. The first example I want to show you, the first slide I want to show you is actually the three marine data services or assets. On the left, you see EMODnet, which is for in situ marine data. On the right, you see Copernicus Marine Service, which is more for satellite-derived observations and modelling capability. And both of these services are feeding into a new initiative called the European Digital Twin of the Ocean. There is now today a common data lake where the data of EMODnet and Copernicus have been combined in one place on the cloud. These data are being optimized for the cloud, and they are being made available together with the latest state-of-the-art modeling capabilities and other analytical tools, completely free of charge. The pilot or the prototype is there now, but over the next few years, this will be really significantly developing. And any data that comes into EMODnet or Copernicus will feed into this European digital twin of the ocean. And then I'll show you just one slide or a couple of slides each from these three initiatives. So EMODnet, which is the European Marine Observation and Data Network. This is the data service that I work for currently. This is an initiative of the European Commission, the Directorate General of Maritime Affairs and Fisheries, which is called DG Mare. You can see the website here, which takes you to the official European portal for EMODnet. And I'm just going to show you in a nutshell what EMODnet offers. I just note that EMODnet has been going around 15 years now. So it's had more than a decade of progress, and now it's an official European service, and we have over 120,000 users per year. But that is growing in terms of the number, but also the diversity of different users, not only in Europe, but increasingly also around the world. With any stakeholder can access this for free. And you don't have to be a European citizen, for example, but the data and the knowledge that is provided by EMODnet is predominantly for the European seas, because that's the core mandate of the programme. So if you go to the EMODnet portal, you will be able to discover and visualise and then download a series of marine data and products. We have more than 65 parameters across 7 different thematic areas across the marine environment, but also human activities at sea. And the way you can discover and visualize is on the left of this slide. You can see a computer with a map viewer. So this map viewer is interactive. You can go there, you can select the thematic, say physics. You could select physics. You can then scroll down and select, I'm looking for underwater noise, or I'm looking for temperature, and then you can start visualizing the different data maps or data products that EMODnet offers. And then from there, you can dive into the metadata to really see, how was this data taken? Is it the right format or the right types of data that I'm looking for? And then there's an option to access directly the data and download it. And the EMODnet service is underpinned by a common metadata catalog. So there are thousands of entries in this metadata catalog, which are underpinning all of the discovery work that is offered. Then in terms of the service offer, I can't dive into too deep today, but this is just to show you again the diversity of parameters that you can find on EMODnet, from the surface to the seafloor and from the coast to the open ocean across European seas. And this is quite a unique asset in Europe, because it brings together both the marine environment and human activities together. Then showing you briefly the power of what we've been talking about, by sharing data, by having the FAIR principles applied to the data and producing integrated data sets, we can, we society, in general, have then access to very powerful information, more detailed seafloor contouring and bathymetry, for example. The bottom right is about human activities. It shows the vessel density, tracks of different vessels from fishing to shipping and yachts. That's through the Gibraltar Strait, so you can see how many vessels and how busy that section of the ocean and the European sea basin is between the Mediterranean Sea and the Northeast Atlantic. And then I mentioned that the interoperability is important, not just for one parameter, but many parameters. This is an example of the seabed habitats that we saw earlier, and this shows the power of having interoperable data from many different thematics. You need, for example, for a seabed habitat map, you need to know the substrate, is it sandy, rocky, seafloor, what's the hydrodynamic energy at the bottom water currents, for example, what are the dynamics at the seabed, what is the biodiversity, the biological zone, but also the species that are living in a specific area. And then if you have all these data together, you can produce a seabed habitat map that can be used not just for research, but also for evidence-based policy making. Then to briefly introduce the next service, Copernicus Marine Service. So this is a sister service to EMODnet. It's Europe's leading service for satellite-derived data on the ocean and the coast, and also has the state-of-the-art modelling capabilities. It's part of a much wider Copernicus service, which has multiple domains from marine to land to climate and many more. And it's a very important service that in our work in EMODnet, we have a lot of partnerships and collaboration with. And this is one example of Copernicus data that is showing the global surface temperature from satellite-derived data. And then the third piece of this puzzle of the marine data services, or the marine knowledge services of Europe, is the European Digital Twin Ocean. So this is really a groundbreaking initiative that will be a long-term initiative, as we understand, at least, from the European Commission. And it's designed to really create a kind of step change in how you can access data and information, but also giving much more public access to computer modeling, big data analyses, and different analytical tools, so that professional stakeholders can access these information to create, to look at future scenarios, for example, sea level rise in 50 years, 100 years time, but also the public society can also be accessing these data. And eventually there should be more visualizations as well, including digital replicas of the ocean, virtual reality environments, etc. So it's really a very big initiative, which has started with the data, of course, as the foundation. And the work that we're doing at EMODnet and the work that Copernicus Marine Service are doing is together really important to bring these data together into this common data lake on the cloud that I mentioned. And yes, this is just what I mentioned, that the ultimate aim is to create a virtual representation of marine and coastal environments around the globe. But this one, the European Digital Twin, is very much focused in the initial stage, at least, on the European data and on being able to serve the needs of European policy or other stakeholders. And then the prototype that I mentioned, that was already showcased last year at a DigitalOcean forum, which was a forum that took place in Brussels, and that's an annual event. So if you're interested in this, look out for the next DigitalOcean forum, which we believe will be in November of this year. Then just a note that this digital twin has many different sort of uses, not only for individual stakeholders, but the actual asset of all these data in one place on the cloud is also going to be a step change and a game changer for accessing marine and coastal data for different applications as well. One is that there are different data spaces being created in Europe. One for the European Green Deal, which needs climate, marine, and also socioeconomic and other domains of data to meet the ambitious goals of the European Union to be a climate neutral continent by 2050. And there are many even more ambitious goals, let's say by 2030, 2040, before we even get there. But also the European Digital Twin is a key part of a digital ocean and water knowledge system, which is a bit of a mouthful, but it's basically seen as a sort of cloud-based data space, if you like, for both ocean but also coast and inland waters that can be serving the needs of EU policy and research and stakeholders under the umbrella of what is called a European Union mission. And the mission is by 2030 to restore our ocean and waters. So there are a number of missions from cancer to the ocean, for example. You can have a look if you're interested and dive into these different missions. But the one that's most relevant here is the restore our ocean and waters, and having this interoperable on the cloud data system is really crucial for serving the needs of the knowledge needs of this mission. Then in terms of the policies that are driving all the work that we're doing on marine data, but also the marine knowledge value chain, in Europe, there are a number of different legislations and directives and strategies regarding open data, regarding the geospatial data and how we share it in terms of the FAIR principles, but also under Inspire, there's also what's called high value data sets. So this directive has identified particular data sets from the environmental domain, so including Earth observation from satellites and marine data, but also including other information that's, wider geospatial data, meteorological data, for example, that is considered high value data sets, that there's even more of an incentive, let's say, or a demand to share these data in an open way because they have clear societal relevance. So there are a lot of frameworks that EMODnet, other marine data services, are working under, and EU member states and nations as well work, according to these directives and strategies as well. So we have this open data strategy, we have the high value data sets, and we have a single market for data, which in some part is, of course, to ensure Europe's global competitiveness and data sovereignty, but it's also ensuring that the data from Europe is also interoperable with the global frameworks as well, and that we can move to have common data spaces at multiple different geographical levels. Then in Europe, we also have a number of directives and strategies. I'm not going to go through them all today, but I mentioned the European Green Deal. There's also a European Climate Action. There's Biodiversity 2030 to address biodiversity loss and ecosystem degradation. And there's also a new one coming on nature restoration as well. So there are a lot of different initiatives that are really driving the need for data and marine knowledge. And then the Restore Our Ocean and Waters mission that I mentioned, which has ambitious goals also linked to the EU Green Deal. Okay, now we've just looked at the different policy frameworks, let's say, and now we're going to, I think, just look at one example. There are hundreds of examples of use cases on EMODnet, on Copernicus, that you can have a closer look at, but one example of how do we take the data into decision making. This is an example from EMODnet and the Marine Litter Database. Because different countries shared their information on beach litter, but also seabed, seafloor litter, EMODnet has been able to create an aggregated, harmonized database of marine litter for Europe. This has really been very instructive and influential to inform the Marine Strategy Framework Directive that I mentioned earlier. This time we're looking at descriptor 10, the marine litter descriptor. And this data has been able to then be assessed, used as knowledge to really inform European scale reports and also have a positive effect. We had a look at this a little bit earlier in the presentation, that the headline now is that marine litter on the EU coastline is down by almost 1/3, and there's been a report of the study that took place, but in general across a European scale it's down by 1/3. And this is a clear example of how, by sharing information and knowledge, we then come to positive support to policy implementation and a positive result in terms of a reduction in marine litter. Then I mentioned that what happens in Europe, obviously, we're working very hard to make sure that contribution is can be harvested and is interoperable at the global level. In EMODnet, for example, now that we have this common metadata catalog, that means that all the data can be read not just by people on computers, but machine to machine readable as well. And the result is that EMODnet can be harvested either automatically or semi-automatically by various global initiatives. One is the Global Earth Observation System of Systems portal, which has many observations from around the world. And another is a Ocean Data and Information System, which is a key data and metadata initiative of the Ocean Decade. And that's implemented by IOC UNESCO and the IODE initiative within IOC. And so that, EMODnet, but also other European initiatives are active contributors to the UN Decade of Ocean Science for Sustainable Development, but also other policy frameworks like the Sustainable Development Goals, and which is, of course, the UN 2030 agenda. Okay, we're nearing the end of this, and then I'll share a few perspectives of my career pathway. But I just wanted to mention that, of course, data services don't just stay still. There's always more data that can come in, but there's also the evolution of the data services themselves. At EMODnet, where I work now, the whole community of more than 130 partner organizations are always working to be at the forefront of marine data service provision. And this links very much as well with the European digital twin of the ocean. But some things that are really coming up in the evolution of the services right now is how can we harness artificial intelligence, not just for the data analysis, but also for how we check the metadata, how we organize the metadata, how we curate the data. There's all sorts of different applications that artificial intelligence could be used for, both in the backend service, but also in the user interface and the analysis as well. There's a lot going on in computer simulations, virtual research environments that are being used by in Europe by different projects now, but will be made available through the digital twin and through the European Open Science Cloud as well. And it's important to note as well that artificial intelligence clearly needs to also go through its own evolution, and it needs to expand to have more cultural and linguistic diversity, so that it really will be fit for use, not just staying, how it is now, which is sometimes restrictive or not as inclusive as it could be. Okay, I did mention that I was going to introduce 2 other acronyms, so sorry for the acronym soup today, but hopefully it gives you just some food for thought to take away. The FAIR principles are really the basis for all data services to be interoperable, but more recently there have been other principles that have been communicated and published on that I wanted to mention. One is that as we go towards a more integrated global ecosystem of data, it's really important that we connect the existing data services, and they all need to be interoperable with themselves, but also trustworthy digital repositories so that everything can talk to each other. And this is the basis for this other acronym, TRUST, which looks at the transparency, the responsibility, the user focus, the sustainability, and the technology of the infrastructure or other types of technology. So that's worth a look if you're interested to look more into the digital repository type principles. And then another really important one in terms of moving to ensure we have more inclusive knowledge being shared, but also more transparency in the knowledge value chain, is an acronym called CARE. Now, this has come, I believe, more from the indigenous data governance conversations, and this has also been published. I'll put the link here. But this really looks at making sure that the data that's being shared, that there are collective benefits back to the data collection efforts, to the providers and the people or the institutes or the organizations that are collecting the data. So this applies beyond indigenous and local populations and communities, but it's really driven from there, and it's a really important aspect of the UN Ocean Decade to make sure that the data and the whole system is very inclusive and transparent. And then the authority to control access if needed is all part of the this chain within CARE. The responsibility, which relates to the provenance, but also the responsibility of who and how to share the data, and then the ethics behind all of that to minimize any harm and maximize the benefits. So that in a nutshell is a couple of other acronyms that have more recently been published on. And then the last shorter part of the presentation is some more personal reflections or perspectives. My career path, I started as training as a marine scientist. So I first did a more general natural science degree with biology, geology. And then I was by then already convinced I would move into more ocean science, but I wanted more a general background in sciences. Then I went on to do postgraduate studies in ocean and earth science at the University of Southampton, which included a PhD in deep sea ecosystem. So it was a biogeochemistry PhD looking at the seafloor community of protists, the foraminifera, and looking at their response to different oxygen gradients in natural oxygen minimum zones. So this was, 3-4 years of academic research, leading a research program myself, and then producing the PhD. And then I'm going to sea as well and collecting my own observations as part of a much bigger program. That within that, I learned a lot about the scientific method and the data handling, etc. But one reflection I would share, that this was back in 2003-4 that I was doing the PhD. So it's a good time ago by now, but it's a reflection that back then data was not really valued in the way that it is now in terms of the value chain. So for instance, I remember at the end of my PhD, somebody requesting that I share the data, which I did, but that was really at the end of the PhD, and I didn't, I obviously collected the data via a scientific method and recorded everything that I needed for my PhD, but I was not given a metadata sheet to record exactly the information that would be needed by the data center at the end. So this was a reflection that I think this has now changed in a good way, that there's a lot more input and advice to scientists at the beginning of their data collection efforts, but I'm interested to hear if anybody has found that differently. And then, so after the PhD and doing some work as a postdoctoral researcher, I saw the opportunity to move to a position that was more science policy focused. That was with the European Marine Board based in Belgium, as working for a think tank on marine science, Foresight. And then in 2019, I moved to my current position within EMODnet and became the head of the Secretariat in 2023. So these are some highlights from the work I do now, where I'm really engaging with stakeholders. I'm talking with the European Commission. I'm attending events at the European Parliament, and I'm really feeling like I'm having an impact in the middle as a sort of knowledge broker, bringing the science and the data and the knowledge to the stakeholders that need this information and making a difference. But the reality, especially after COVID, is that a lot of these meetings, governance meetings, conferences, etc., have moved online. And so over the last few years, having gained experience in science policy and seen the bigger picture, I really missed going to sea and taking observations myself. And so this led me in 2022 to join an expedition by Sea Women, which was an expedition to the Norwegian Arctic. You can see on the left a picture where I'm holding a scientific grade hydrophone for passive acoustics, and that we used, but also the pictures I've already shown of the more cost-effective citizen science-based sensors that we used as well. You can see the list of all the different types of work that was going on, and that was a whole collective effort, not by me personally, I should say. It was really a collective effort of many people on the expedition together, but it was a way to collect data which could be then provided for repositories and services and have an impact, but also to use that data for storytelling as well in communication, science communication, and to really communicate about the region, about the ecosystem, about the orcas and the other whales and themselves, and to engage society beyond the traditional natural science, let's say. I just wanted to mention with that on these expeditions and in any voyage or expedition that you might do on the ocean, it's always worth checking which information might be already available in your region. So for instance, in Europe, I went to the EMODnet repository and service and pulled out this high resolution bathymetry, which was basically the route and the area that we were going on in the expedition, which just, you know, sets the context and is, again, this data visualization can be used for storytelling beyond also, of course, informing where to sample, which depths and which regions would be good, and also to then add the track of the expedition too. Then I've mentioned the sensors already, but I just wanted to highlight again, you know, these sensors here on the screen are scientific instruments used by researchers to collect water samples to assess the temperature and the salinity that they infer from the conductivity and the depth. But you can see how many people are involved, how big the instruments are. And if you're on a citizen science campaign, you really don't have the luxury of using those expensive and big instruments. So really, for citizen science, we need to think of other cost-effective sensors or smaller sensors or more user-friendly sensors and instruments. And one example is this castaway sensor that I was kindly loaned, two different instruments, one from the University of Gothenburg and one from Andøya Xylem, based in Norway, for the citizen science expedition. Then here's just a highlight of the data that came out of that expedition. So we ended up with a series of depth profiles, surface to 15 meters, because it was quite restrictive to get, you know, much lower than that because of the way that the sensor would go in the water. But we got some really nice depth profiles of the upper ocean profile, and really having the signature of the freshwater input from, you know, the Arctic land and the ice and snow at that time of the year, the runoff from the rivers into the ocean. So you have a more freshwater signature at the top, but really nice data that could then be contributed to the global data ecosystem. And then we also had the whole community of the expedition were going in the water, snorkelling and looking at orca and humpback whale observations, both behaviourally, but also taking some data to look at the underwater communication of the whales. I do have a passive acoustic profile, which is credited to Sarah Neal, but also the help of Aya Walraven, who I think might be on the call. I don't know if it's possible to play this. I'm going to try, but I'm not sure, Laura, if this will work. So I'm not sure if that was audible. Apologies if not. I think in the interest of time, we might need to move on, but maybe towards the end, if once we finish, then Laura, maybe you can share it to see. But it just gives you an idea of this is what the data looks like from a passive acoustic with the underwater sound. And again, very powerful for storytelling as well as scientific data. Then I finally wanted to note that the expedition in 2022 was fantastic, with women from very different backgrounds, not just scientific backgrounds, but very different professional backgrounds. And that really opened my eyes to the power of bringing together people from very different disciplines, not just scientific disciplines, to do activities together and to use the power of data, but also imagery, the arts, including music, etc., to really tell powerful storytelling. And that has led me to apply for and be selected for another expedition, which will be going to Svalbard area in end of June this year. It's called the Bears, Ice and Glaciers Arctic Climate Expedition. And it's going to be on the vessel, the Sylvia Earle. And this will do citizen science data collection efforts, but also very much focus more on the storytelling aspects, using arts and music in combination with scientific communication. So I'm really excited that I'm going on this one, and watch this space for more information on that. So the key takeaways from this workshop and this presentation, you've seen there is really a deluge, a huge volume of ocean and coastal data that already exists. But the key takeaway is that the data themselves are not useful unless they're fair. And it all starts with the metadata. If we don't have the information describing the data, it's not going to be fair, it's not going to be used. The fact that Europe has a mature capability for marine data services and it's already contributing to the global system. However, there remain many gaps in marine knowledge. So we need, firstly, more sustained in situ ocean observations to fill these gaps in space and time, including the coast and land sea interface, but also the deep ocean where the data right now are really scarce. And we also need more knowledge on biodiversity and ecosystems because the sensors and the samplers are less automated right now. And this is a really emerging area and it's much needed so that we can understand biodiversity loss and ecosystem degradation. And finally, that the engagement of society in this whole value chain in the citizen science data collection efforts and also the transdisciplinary nature of these actions is really a huge opportunity. I hope that some of you, if you're not yet engaged in citizen science or ocean science, that you may be convinced by this presentation to have a look and dive in, because there are many citizen science opportunities, both terrestrial or ocean-based citizen science, but also that citizen expeditions, all sorts of different campaigns and recreational activities at sea, from boating to surfing, can all potentially play a part in collecting data. So with that, I will close and thank you very much. Apologies if we went over time. If you're interested to contact me further, my LinkedIn profile is here on the QR code. And I thank you very much.
Thank you, Kate. That was amazing. Super informative and so much information. And luckily we've recorded this, I hope, Michaela.
Yeah, that's the plan. Hopefully it all moves to plan. But really, again,
great
job.
Yeah.
Yeah, it's nice.
Hopefully we can upload this to YouTube, so that if you did miss anything, or I'm sure there's lots of people who wouldn't be able to make it because of their time zones, we can upload it to our YouTube so that people can catch up. But yeah, thank you, Kate. If anyone has any questions, now is the time to ask them. So you can either put the message in the chat or you can turn your microphone on, and feel free to ask away.
So I see one, Laura, from Mary Neely, who's asked about the challenges with citizen science. I don't know, Mary, if you'd like to ask anything further on that, or I can just respond.
I just was specifically wondering about meeting the FAIR data principles. For instance, findability, interoperability, especially. And I wondered if you could opine on maybe if the planner of the citizen science project needed to take that into account, because citizen scientists wouldn't necessarily be aware of that need.
Yeah, it is a great question, and I did not mention it, so great we have time to elaborate a little bit. The challenge with citizen science indeed is if for example I was to set up a citizen science campaign tomorrow and I just gathered a group of people, we went and collected some water samples and then didn't pay attention to how we collect those data and recording the right information, then indeed those data may not be useful for scientific analysis for sure, but not even perhaps for other stakeholder applications, and they certainly wouldn't necessarily meet the FAIR data principles. So what is really important in citizen science is that it's part of a framework, so that firstly the citizen science organization or initiative takes time to really have a methodology for the data collection that is standardized, so that if different groups are going different times of the year or different locations on the same day, that those data can have some kind of standard approach. Then to have a minimum set of metadata required, so that everybody records the same level and the same types of information. And for this, actually, the data services like EMODnet that I work for are really starting to close the loop and have these closer partnerships with citizen science initiatives, because we believe that we can provide some guidance in terms of, you know, how they collect the data, what types of metadata they collect. Will be if we can give guidance that's easy to follow but is in some way standardized and can be used, then we can firstly make sure those data end up in a repository or a service like EMODnet, making it more impactful. But hopefully there'll be more of a sort of virtuous cycle that the citizen scientists themselves, they see that their efforts are making a difference. Like the data is then, they could see it pop up in a service like EMODnet. And that's also something we're trying to work harder with the services that we work on not just metrics that track who downloads the data, but to be able to give the data providers more information on, you know, where their data has gone and how it's been used, because we believe that will also drive, showing the demand drives more funding, let's say, for not just citizen science, but other data collection as well. So I hope that answered a little bit your question.
I think there's a couple more questions in the chat now as well, Kate.
Let's see. So I'm just going from the top of what I can see. What inspired you to pursue your ocean career? Well, I don't know about yourselves on the call if anyone's done an ocean career, but I was not a classic Jacques Cousteau watching child. I actually didn't go to the sea that much, but what I did do is just be very curious about nature. I remember as a child already being very curious, and that's what led me to more a natural science degree. And the more I read and understood about the ocean, I realized that it needs understanding of so many different aspects of natural science, as well as even more like, you know, social science, etc. It just fascinated me, really, this you know, huge part of our planet that was, at least when I started, very underexplored, and it remains still very underexplored, really. So really, I think it was more the curiosity and the interest in the natural world in general that led me there. Are there pathways to working in marine science or conservation for people who don't have traditional academic science education? Absolutely. I can't tell you off the top of my head lots of you know, examples, but I do know that, you know, non-governmental organizations, data services like the one I work for, not everybody certainly doesn't have the PhD level in marine science. They might have a more wider environmental degree, but there's also many ways that you can be involved, whether it's in citizen science initiatives or in other organizations that you don't need a classic background of science. And I would add as well, if you are interested in engineering or technology or IT, you know, cloud computing, all these aspects, these are really much needed skills that are needed for the marine knowledge value chain. So the observations themselves need technology developers and operators, and then the digital services definitely need more IT savvy and digital service expertise as well. So there's a whole range, I would say. But also, if you're interested in science policy, you could come from more a policy perspective background and not need the marine science background, but then come from the other direction. So yeah, there's a few different ways, I think. Where to find mentors in this field that work with data and AI? I would suggest through LinkedIn to start, you know, searching and following people or initiatives that look interesting to you, that may have a profile or may be conducting work. For example, following EMODnet on LinkedIn, but also there are other initiatives, of course, as well, which might be a good start. And then I think mentors can be either very sort of informal, like a non-structured mentor where you engage with someone particular that you would like an exchange with. But there are other programs like through in Europe, there is a EU for Ocean, which I can put in the chat, which is a network of ocean literacy. And that has 3 components. It has a youth component up to 30 years of age, I believe, then a schools component to get more ocean science in the curricula, and a professional platform, which is the Marine Maritime Professional Platform. And that has a mentorship scheme linking the youth with the platform members. But it may not also be restricted to the youth per se. I think it's also including early career ocean professionals as well. So then it's not age dependent, but that could be a good one. Someone's put Dawn Wright. She is a great person to follow. She's very inspiring, from Esri. Yes, exactly. Then the expeditions, let's see exactly what science involved in. Yes, the Big Ace expedition, I would contact, if you're interested, I would contact the organisers, because there are a series of scholarships, or there were at least when I applied. So I would definitely get in touch with them if you're interested. There is a science lead, and some of the science will include microplastics data collection. But I can't give you the full information of the full science program yet, because we're still finalising it. It's still a couple of months away. And there's also, leads in different arts. Like I play music, so I'm going to be playing music on board as well. So there's a whole load of different areas you can get engaged in. The data analysis question, sea turtle behavior analysis underwater. I wouldn't be able to answer your specific question of sea turtle behavior, but what I would suggest you do is you could always, I can put an email in the chat as well. I'm very happy to answer some questions offline if you want to contact me if we haven't been able to answer questions today. And what I can do is hopefully find you an expert who can answer your question. Okay, so this is my emails going in the chat now. And yes, some people have connected on LinkedIn, fantastic. So yeah, don't hesitate to connect with me on LinkedIn, or yeah, have a look at EMODnet and the other work that we do. So I think that answers most, if not all, questions. Was there anything, Laura or Michaela, that you may have seen that I missed?
I don't think so.
I don't think so. I think you've covered everything, yeah.
But lots of good questions. And
Yeah.
thank you so much for your time and giving such good and detailed answers to everyone's questions as well. And also providing your email address. That's always very, very kind of you to do. And offering to answer questions. So super appreciate that. But if there's no more final last minute things, then maybe we can wrap it up, and we will post the recording of this video. Fingers crossed that technically everything worked out on my side. I'm sure it will. It'll be up on our YouTube, and we'll also post it in our member section on our website as well. But yeah, thank you so much, everyone, for such a great discussion. And Kate, thank you again for such a great presentation. It was really amazing.
Thanks to everyone for joining, and thanks to the team organising it.
Awesome. All right, guys. Bye.
Have a good evening or day. Bye.